let's revisit Flatzoid's disastrous experiment. Let's take a look at Flatzoid's hypothesis and prediction. His hypothesis is that the mass of the object determines the amount of force the object will be attracted to the larger mass. If I remove mass of the object, it should show less attractive force and thus not accelerate at the same rate towards the ground as when shown to have more mass. Bearing in mind he never measured anything, let's carry on. Independent variable, mass. Dependent variable, more mass would show acceleration towards the larger mass, in this case the ground. Null, mass has increased and yet shows not to accelerate towards the ground.
Make a prediction. If I remove the mass of the object, in this case the peel around the orange, in the fish tank it will show, based upon the postulation, the orange will have less mass and thus have less attractive force. This postulates that the orange will either remain at the same position or it will go up as the counterbalance forces will be stronger. More mass means down to large mass. Less mass, same or goes up away from the large mass due to buoyant forces.
This has shown that the ratio between object and the medium relies solely on one another, and the relationship of direction between the two is dependent only on its displacement relationship. What medium is there to displace in a vacuum flats? Your hypothesis completely fails there. See Flatzoid, you had two independent variables, the mass and the volume. You changed the mass of the orange and the volume of the orange. You didn't change the mass alone while keeping the volume the same. Therefore, you had two variables that were changed. And this is why science doesn't prove things, because you overlooked this. You thought you was only changing the mass, but you also changed the volume. So you changed two variables. And this is why science doesn't prove things, because there may always be variables that you don't know about yet, that you haven't discovered yet. So therefore you can't say it proves anything, because there might also be something unknown to you that you haven't taken into account.
This is why you're stupid.
So what happens if Flatzoid's disastrous so-called experiment is done properly? Let's find out.
So I found that using a spring scale with different size, the containers are all the same size, but they have different masses. And I do need a volunteer to help me read the spring scale. Come on up. Hello, Peg.
Hello, Annis.
All right, I would like you to do this readings.
Okay.
And I would like our other volunteer to write on the board. So Jan's gonna, all right, would you read that for me and tell me what the mass is when I weigh this in air?
And that's in grams, so it would be 130.
Okay, now we're gonna put it in water so that it's submerged.
Well, the mass is going down.
Yes.
80.
80. Okay, so we have an apparent mass loss when we put that in water. We've displaced a fluid, water in this case, right? Well, what do you suppose? Let's try some other things.
Okay.
Here's another one of these containers, same size, but different mass.
70 grams.
70 grams. Let's put that in.
21 grams. We'll call it 21.
Okay. Okay. Now, let's look at the board for a second. Jan, could you do a subtraction so we could look and see what the mass loss is here? You've got 50 grams, 49 grams. How about if I take another one, and I'll make it just a little bit heavier. Just don't lose your marbles. All right, so would you read that for me?
140
140 grams. Would you like to make a prediction?
Well, it seems to be about 50 grams difference. How about 90?
All right, let's try that.
92.
All right. Spring scale isn't the best, is it?
Right.
Okay. Now let me give you one. This one is what?
Well, that's going to be a problem. That's only 24 grams to begin with.
Oh. What do you suppose will happen when I put it in the water?
I don't know. The scale doesn't go past 0.
So what do you think?
It floats.
It floats. My goodness. And the scale reading is?
0?
0. Okay. Well, do you want to make a prediction, or do you want to think about why the difference was the same on those first 3?
You said something about displacing the water, and they all look about the same size, so maybe they're all displacing the same amount of water?
And what volume do you suppose they are?
Water. 1 gram per milliliter, so 50 milliliters.
I think you win. Thanks, Betty.
What do I get?
Now in freefall, water is still displaced, so why aren't things floating and sinking now?
So I'm going to do this again without this being a sealed container, because some daft twats out there seem to have a notion that this is going to go differently. Probably the same people who don't comprehend clouds. Daft twits. So anyway, here. No lid. This is not a sealed container. Again.
You look like you've had a bad day.
Tell me about it. Oops, I did it again.